Okay, so good morning, ladies and gentlemen. I would like to present here the state of GRASS on behalf of GRASS community. Let me also thank to my GRASS colleagues and friends who contributed to this presentation. So, yeah, next slide. I will try with the mouse. I can just switch, or how can I can switch, or you will do it for me. Okay, I will try. I don't see the mouse. Doesn't work? Yeah, but I'm moving with that and doesn't move at all. So if I can just ask you to press the space and just... Okay, great. So go back, please. Thanks a lot. Okay, so my name is Martin Landa. I'm working at the Department of Geomatics, Czech Technical University in Prague. I started to use GRASS and to contribute to GRASS in 2003, so it means like 20 years ago, which is half of my life. So you can imagine that, I mean, GRASS is like part of my heart. It's half of my life. I was just helping to GRASS to be better, and it's a special moment for me here to present GRASS here. You can see from my contribution that in 2017 I switched to another project, which is my family. So you can easily see that my contribution to GRASS went down. So this moment is like nostalgic for me that I can present GRASS here, and it's a honor and pleasure for me. So please, next slide. So what I will go to present here. First of all, I would like to present GRASS, what it is for newcomers. Then I will present new features in GRASS 8.3, which is like a newest version of GRASS. I will also highlight community contribution. I would like to share with you, I mean, the approaches, the ways how you can be involved in GRASS. And at the end, I will present, I mean, how we celebrated GRASS 40th this year. My colleague Marco, he was presenting that QGIS celebrated 20 years last year, so we celebrated 40 years this year, which is quite extraordinary. So please, next slide. So what is GRASS? GRASS stands for Geographic Resource Analysis Support System. It's open source and free software GIS used for geospatial data management, analysis, image processing, spatial data modeling, and visualization. It's very powerful in geospatial data processing. It was originally developed in the early 80s by the US Army, and in 2006, GRASS was a founding member of OSGeo. And as I mentioned, this year we are celebrating 40 years of continuous geospatial development. If you just visit our GitHub repository, maybe you could be disappointed, because I mean, if you just search or look at the history like the first commit is like in 2003 or something like that. But I mean, there is a separated GitHub repository, which is called GRASS Legacy, which really contains the history till, I think, GRASS 3 is the first version which is included. So if you are really interested about GRASS history, we have separated GitHub repository which contains almost full history of GRASS development. So please, next slide. So GRASS is really, really powerful, as I mentioned, in geospatial data analysis. It contains more than 400 tools which allows you to process your data. There is also, I mean, beside of these core tools, there is more than 400 user-created tools, which are called add-ons. So I mean, everyone can contribute to GRASS via these add-ons. So please, next slide. So about the roadmap, last year in Firenze, my colleague, Markus Netteler, was presenting the version 8.2. So it's a pleasure for me here to present the new version, which was basically, or actually, released a few days ago, 1 week ago, GRASS 8.3, which brings nice, cool features I'm going to present in the next slides. I just wanted, or I would like to describe how we are versioning GRASS. We are using a semantic versioning approach. So the version contains three parts. The major parts, which brings new features and possibly backward incompatible changes. The minor version, which brings new features and fixes, and the micro version, which brings only fixes. We change the way how we are using the odd and even minor version. I mean, till GRASS 8.2, we distinct between odd and even minor versions in the way that, I mean, odd versions were used for development phases, and even versions were used for release. So it means that, I mean, if you just check the roadmap, there was GRASS 8, and the next release was GRASS 8.2. We changed that with starting with 8.3. We are using every minor version for release. So this year we released 8.3. For the next year we are planning to release 8.4 and so on. So this changed. So please don't be confused from that. So please, next slide. So I was mentioning that there is a new GRASS version, which was released just 1 week ago, 8.3. So let me present just selected new features. I mean, for complete record, just go to the GitHub and check the news, which contains, I mean, full list of changes. So please, next slide. So first tool I would like to present is Vornai, which is a GRASS tool, and I mean, in a GRASS 8.3 version, it allows to create skeletons and center lines. This improvement was done by Markus Matz. Please, next slide. Also the module which computes a different type of vegetation indices was improved. This tool is called i.vi. There's a new support for soil line slopes done by Ondřej Pešek. Next slide, please. There are also plenty improvements in graphical modeler, which is one of graphical user components. This new feature I'm going to present here, the GRASS graphical modeler allows to export your model into the WPS process, so you can easily convert your GRASS model into the WPS process provided by the PyWPS project. So please, next slide. There is also Jupyter Notebook integration in the GRASS environment. It was introduced in version 8.2 last year, thanks to the Google Sum of Code project. GRASS 8.3 comes with various stability fixes, and there is also like a new feature which is called series map, which allows to use in the notebooks animated vector or raster series. It's still hanging the pull request, so this is still some work is ongoing. So please, next slide. There's also faster support for external data sources. I mean, GRASS is using its own raster and vector format, but beside that, I mean, you can easily read external data formats in GRASS thanks to the GDAL library. So you don't need to import your data into the GRASS native format. You can just read them. You can just read the files or the external data sources directly. This functionality was significantly improved. That, I mean, this reading process of external data sources was improved like 5 times. It's faster. For workflows where you're just reading like portion of the data, the improvement can be I mean really like significant, more than 20 times, for example. So please, next slide. GRASS 8.3 also comes with improvements related to the source code maintenance. We fixed a lot of compiler issues. We also reformatted C and C++ source code using a CLang formatting procedure, and we also improved the CI in this regard. So there is also effort to parallelize a lot of GRASS tools. So it's like ongoing long-term project. Please, next slide. I will present new tools or tools which comes newly with parallelization support in GRASS 8.3. There are 5. Three are written in C. We use OpenMP I mean, to support parallelization, and there are 2 Python tools which were also parallelized. So please, next slide. But I mean, beside of these 5 tools which were presenting in the previous slide, there is a bunch or number of tools which are already parallelized, including a GRASS Python API. Yeah, but a better graphical user experience. I mean, it's an important topic for GRASS, of course. In version GRASS 8, we did really like a huge change. Because I mean, for dozens of years, maybe from starting with version GRASS 5, there was a welcome screen, and it was obstacle for many newcomers. So after really long discussion, we decided to change this concept. So in GRASS 8, there is no welcome screen anymore. Please, next slide. Next slide. So no more. So how GRASS starts? Starting with GRASS 8, GRASS just opens like a demo project. And what is important, we are trying to navigate or newcomer to do next steps, because I mean, what is important that the user understands that this demo project is not, shouldn't be used for real work. You should create a new project, import your data, and continue. I am using here a term project, but I mean in the GRASS terminology, we are calling or we are using a term GRASS location. So project is not perfectly correct, but maybe it's more understandable for I mean newcomers to GRASS. So we changed this concept completely, which was I mean really huge change for GRASS starting procedure in a graphical user mode. But of course, I mean the GRASS power still stands, I mean in the command line that you using GRASS on the server like a computational engine. But also we are taking care about users who want to use a graphical user interface. I mean both groups of the users are very important for us. So with GRASS 8.3, I forgot to mention this part. Beside of like changing how GRASS is starting, we also, I mean, traditionally GRASS GUI is multi-window layout based. So you start the GUI and you just multiple windows pop-ups. We also introduced support for single window layout. And in version 8.3 this year of the new version I am presenting here, this single window layout is by default. So if you just start GRASS first time, you will get this single window layout. So please, next slide. Also, we did a lot of improvements in this single window GUI. Here on this slide, there is like a GRASS mini project. I will be speaking about that in the next slides. So you can see that I mean we changed the layout of the console pane and so on. There are various changes, and please next slide. I need to speed up. We also improved dark theme support. So if you like to use dark theme, GRASS is supporting that. Please next slide. And here I would like to highlight contribution from the community. I mean, there are, as I mentioned, there are core tools, but there are also tools which were created by the GRASS community. We call them add-ons, like something like extensions. So let me present a few of them. There is a new add-on which derivates a single elevation value for water bodies based on LiDAR data, done by Anna Petrashova. Please, next slide. Random walk simulation, a tool which allows you to, or which enables you to generate a 2D random walk with multiple parallel walkers and so on. Please, next slide. There's also a tool which allows you to plot or draw box plots for rasters which are registered in the space-time raster dataset. This is like a really important for GRASS. GRASS is very powerful when you are working with space-time data. We have like a framework of multiple tools which allows you to work with space-time data series effectively. There is another add-on which allows you to access a threads data servers in GRASS. Please, next slide. Yeah, so how to be involved? I mean, our community is open for new contributions, of course. Please, next slide. We are on GitHub, so I mean, if you are familiar with GitHub, our project is working in the similar way as other projects. You can create issues, pull requests, everything is publicly visible. You can discuss on GitHub, discuss pages. Always pull requests are welcome. As my colleague Marco mentioned, we like issues, but we love pull requests, of course. So we also changed the way how we are supporting the GRASS translation. We migrated to Osgo web plate. So this is, I mean, very important. If you want to contribute to GRASS, please try to improve documentation, tutorials, and so on. This is like very important for GRASS that we have good documentation which can be used and which will be usable for newcomers. You can also contribute by material on social media and also answer the question on GIS forums and so on. So this is like nothing special comparable to other projects we are working in a similar ways as other projects. Please. Yeah, sponsoring. This is also a big issue for GRASS. We love sponsors, of course. You can contribute by your time. You can contribute by money, of course. Organizations can contribute as a regular sponsors and so on. So we are, of course, open for this kind of support as I mean other open source GIS projects, of course. So please, next slide. Yeah, we have a special program for students. I mean, there is a Google Summer of Code project we are trying to participate. But I mean, what is important that we would like to support students for, I mean, longer time, that they can maybe finish something what was not completely finished in Google Summer of Code project and so on. So we have a special program for supporting students. It's also, I mean, it includes actual coding, but also, I mean, bug fixing, improving documentation, and so on. So please, next slide. Yeah. We celebrated GRASS 40. We did our best. We met in Prague. There was a GRASS community meeting. So we enjoyed a lot. We celebrated a lot, as you can see. Please, next slide. So we met basically 1 month ago or 3 weeks ago in Prague. And yeah, we spent 5 nice days just doing what we like. I can see few of participants here. So I hope that you had the nice time as me. So please, next slide. So as you can see, beside partying, yeah, we did a lot of work. Next slide. Party. Yes. And we need to thank our sponsors, of course, because without of them it wouldn't be possible to organize such great event. So thanks to Osgo, thanks to GRASS GIS, thanks to Osgo, Japan, and very importantly, many individuals. So and also thank to Czech Technical University for providing a venue. Next slide, please. And I will just show some outcomes. Please, next slide. So we released H3. Next slide, please. We did some progress in translation to CMake. GRASS is using auto tools, so we are trying to move to CMake. We also move Docker images to the official Osgo Docker Hub organization. Please, next slide. Yeah, we did improvement in graphical modeler, so now it's integrated into the single layout window. And we also did the first step to convert our manual pages in HTML to Markdown we improve or it will be easier to maintain the documentation also for outside contributors. So please. And also my colleague added a new export functionality to GRASS GIS modeler related to actinia.